Today we're going to be covering how we're solving equations with variables. We're specifically going to be looking at linear equations in this process and with the examples that we're going to see, but this pertains to a lot of different problems where we're working with equations and variables in general. So I have our steps in our process written out here. I would recommend, as necessary, pausing the video and writing the descriptions of each of the steps down for yourself as necessary. That's why it's up here and on display for you. So use that as much as you need to. But let's dive into each of our steps as we're going through them. Our first step, we want to identify the variable that we are solving for. Should be a little 4 in there. Yay, typos. Seems kind of trivial. Seems like, well, okay, I'm given an x, I'm going to solve for x. I'm given m, I'm going to solve for m. We're going to see some problems later on where we're going to have multiple variables showing up, and we want to still have this habit established early on and use it there where we say, this is the thing I'm solving for, I'm going to keep using that. That's the thing I'm going to try and get by itself. Our goal with it, as we just said, is to isolate that variable to one side of the equation. We like to have it equal a number on the other side if we possibly can. Sometimes that happens, sometimes it doesn't, but it's kind of a nice thing if it's able to show up there. But more than anything else, identify the variable and get that thing all by itself on one side of the equation. That's our overarching goal with this entire process here. Now, my recommendation, if you're following these steps, is first and foremost, simplify both sides of the equation individually. Should make that individually note known. If you are writing this down, I would highlight, circle, bold, underline this individually part. We're doing each side all by itself. Nothing should be moving and adjusting on either side of this equation. Remember that if we see the word simplify, we should think right to our order of operations, the acronym for that being PEMDAS, parentheses, exponents, multiplication, division, and then addition and subtraction. I do also have a hint in here as something that you could do, and we will talk about this in later videos, but you can also cancel fractions out after you've eliminated all grouping symbols, parentheses, brackets, and the absolute value signs, and exponents from both sides of this equation. It's not required, but it does make calculations later on a little bit easier. And again, we're going to cover this in a later video, but for right now, we're just going to focusing on simplifying both sides of the equation individually before we do anything else. Once we've simplified each side of this equation, we are then going to go into and actually start solving this thing. My recommendation is if we have variable terms on both sides of the equation, we want to eliminate all variable terms on one of those sides. Again, our goal is to get the variable all by itself on one side of the equation, so if it's on both sides, we should probably get rid of it. My recommendation also is a little bit of a hint for you. It'll eliminate the lower valued variable term to help later on in the process. This is also sometimes referred to as the lower valued coefficient, but means the same thing with how we're going to work through this. We are going to do this eliminating with adding and subtracting to both sides of the equation. Once we've done that, we have all of our variables on one side of the equal sign. Our fourth step then is to isolate the variable term on one side by eliminating all constant terms on that same side. We may need to do this, we may not need to do this. It depends on the problem and the numbers and things that we've been given, but if it shows up like that, then we are going to need to do that. And again, with this one, we are going to add and subtract from both sides of the equation to get this desired result happening here. Once we've done this, we should have the variable term on one side of the equation. We have a constant, which is just a number, on the opposite side. And then we have one final step to go. We want to isolate the variable by eliminating the value and sign attached to that variable, if it is anything other than 1. The value in the sign is also sometimes referred to as the coefficient, which you'll see in different textbooks and things like that with how they describe this, but we want to get rid of that coefficient in front of the variable if there is one that is there. we want to solve for a single 1x or a single 1n or a or whatever the variable is. And we don't want anything else that's sitting in front there messing with that. How we're going to do this is going to be by multiplication or division to both sides of the equation. Remember that if we are going to change one side of this equation, we have to change the other side the exact same way. So steps 3, 4, and 5 here, if we add to one side, we need to add to the other side. If we subtract from one side, we need to subtract to the other side. If we multiply to one side, we multiply to the other side. If we divide to one side, we divide to the other side as well. And after this, we do have an optional step showing up here, but we can check our final answer in the original equation. We plug that back into the original thing that's been given to us, and then we simplify each side individually, applying PEMDAS in that regard. If both sides are equal to one another, then it is indeed the correct answer, and we can walk away from this knowing, hey, 100%, we're going to get full points on this thing, we're good to go. Now I'm going to be showing you a couple of these steps here with some fairly quote-unquote advanced looking or complex looking problems, and that's specifically because I really want to emphasize this simplifying both sides of the equation step. A lot of people do not value doing this every single time they're going through problems, and I think it tends to make later steps way more painful. So if you'd like to give this route a try, this is what we're going to be doing. I have 4 examples listed right down here. No spoilers for our answers just yet, but we'll dive into each of these and see how we apply this process. So here we have our first example. We have 4 times the quantity 22x minus 17x equals 3 times the quantity x minus 9. Now, as our first step says to do, we're told to identify the variable we are solving for. So we're solving for x here. So I'm just going to write off to the side here for myself x. So I know that's the thing I'm solving for. Some people like to circle if they want to. It's your call, but just making it clear to myself this is what I'm solving for. So our goal is to get x all by itself on either the left side or the right side of this equal sign. Doesn't matter which one, but we want it on one of those sides all by itself. Great. Moving on to our second step that we had, we're told to simplify both sides of the equation individually. So I have stuff that's going on over here on this left side, stuff going on here on the right side. The reason I recommend that we simplify each side individually is because this is a mess with how we look at it right now. This is also kind of a mess. We're going to see worse later on. So let's just start with cleaning this side up, and then we start adding, subtracting back and forth. Let's clean this side up, and then we can start adding, subtracting back and forth. Okay? So what I'm going to do, and I think this can be helpful early on as we're going through this, if you have a note card or an extra piece of paper or something nearby, cover up this right side of the equation. You can leave the equal sign visible, but cover up this entire side because we're not going to care about it right now. We're just going to focus in over here and use our order of operations to simplify this thing down. So if I'm going to simplify this, PEMDAS says that I need to go and work inside the parentheses first. Can I combine anything inside here? Yeah, I'm going to get 22 minus 17 because these are both variable terms. I'm not doing anything with the 4 out front. That's going to give me 5x. Bringing the equal sign down. And now I have 4 times 5x. This multiplies together and it gives me 20x. Bringing the equal sign down just as it is there. Excellent. So now as we can see, this is way, way, way nicer to look at and probably work with than what this original thing was. So this is as far as I can go with simplifying the left side. Now let's go take a look at this right side here and see what we can simplify. We're going to ignore everything on this side. We're just going to focus in over here. So I have 3 times the quantity x minus 9. So I can use the distributive property and multiply. Whoops. Different blue pen. There we go. It's actually visible now. So I can do 3 times x and then 3 times minus 9. Well, 3 times x is going to give me 3x. 3 times minus 9, that's going to give me minus 27. Now check, can I combine any like terms here? No, I cannot. I have a variable term and I have a constant term. Variable terms and constant terms can never combine together, so they're just going to stay separated like this. So I can't simplify this any further. Looks like I have an extra line showing up here, so I'm just going to bring this side down and rewrite it like this. There's absolutely nothing wrong with rewriting something from one line to the next if it's staying the exact same, but a lot of people think there is, and I just want to debunk that right now. Nothing wrong with doing this. So now, great, we've just finished step 2 in our overall process. This left side looks way simpler to work with. This right side looks way simpler to work with. So now, our third step in our process says to eliminate all variable terms on one side of the equation. If we're noticing we have a variable term over here, we have a variable term over here. I don't want x's on both sides, I want it on one side. Doesn't matter which side we choose, which one you want to choose, we just want x on only the left side or only the right side. So this is ultimately a call that you can make for yourself. There isn't a right or wrong, it's just one where you need to make that decision and then commit to it. If we are going to apply the hint from our process that was listed earlier, then we are going to eliminate the lower valued variable term. Meaning, if I'm looking at the x over here and the x over here, which of these coefficients is lower? In this case, it's going to be the 3. So I'm going to eliminate this 3x on the right side. So I'm going to subtract 3x on the right side. I am now changing this right side of the equation. And if I am changing this right side of the equation, then I need to change the left side of the equation. So 20 minus 3, that's going to give me 17. The x comes down the exact same way. And I have this negative 27 left over here. Some people like to write in that these things cancel out and they'll cross it out there. If you'd like to do that, you can. I'm going to leave it without the little cross in there, but you do what works best for you. Now we can see, hey, we've got x's all by themselves. We've got, or at least the variable terms all on one side. So great, our third step is done. If we look at step 4, it says to isolate the variable term on one side by eliminating all constant terms on that same side. So do I have any constants that are adding or subtracting at the end here or over here at all? No, I don't, which, hey, that's kind of nice. Step 4 is already done for us. We don't need to do any other addition and subtraction here. Step 5 is telling us then, isolate the variable by eliminating the value and sign attached to the variable if it's anything other than 1. Another way you could phrase that is I want to eliminate the coefficient in front here or a coefficient that might be sitting right below here if there's division that's taking place. So 17x means 17 times x, so I need to undo that multiplication with division. So to get rid of that, I'm going to divide both sides by 17. And again, if you want to show, hey, that cancels out there, you're welcome to do that. I'm going to leave red line out there. And on the opposite side, I'm getting negative 27 over 17. With all fraction answers, we always want to check, can I simplify this down any further? And off the top of my head, I don't believe we can. 17 is a prime number. The only thing that divides into 27 other than 1 and 27 is 3 and 9. Those don't go into 17. So we are done here. And we have our final answer. A couple things, final pieces to note with this. When we are simplifying like we're doing up here, we are not actually changing and manipulating either side of this equation. I am simply rewriting this left side from this complex form into a simpler form. I'm rewriting this right side from this form into a simpler form here. So once I have fully simplified things down, then I actually start adding and subtracting stuff back and forth. This is generally something that a lot of people have questions with about, well, I'm multiplying a 4 here, why am I not multiplying a 4 here? And that's because, again, I'm just simplifying in my first few lines, After I've simplified everything, then I start actually changing and manipulating both sides of this equation. So I just want to reiterate that here with our first example, because we're going to see that happen a few times in our next few examples. Alright, so we're looking at our second example now. We are being given 8x plus 6x is equal to 4x minus 80. We're going to follow the exact same process and same steps that we did previously. We're going to go through them at a little bit faster pace, so hopefully this video doesn't become an hour plus long. Fingers crossed on that. But we're still following the same steps. Slow down, go back in the video as necessary as we're going through this particular problem. So our first step, identify what we are solving for. We're solving for x. Again, I'm going to make a little note of that to myself here right off to the side. And I'm going to try and get x all by itself on the left side or the right side of this equation. Doesn't matter which one, but I need to pick one and commit to that. So now, after I've done that, I need to simplify the left side, simplify the right side. So I'm going to focus on this left side first. I have 8x plus 6x. That's going to combine together. I'm going to get 14x. I can't do anything else with 14x. It's as simplified as it can be. Perfect. I'm looking at the right side, and I'm seeing I have 4x minus 80. I can't add or subtract or simplify this down any further because I have a variable term and I have a constant term, and these things can't combine together. Well, that's great. It means I just bring the 4x minus 80 down, and hey, now both sides are fully simplified. Moving on to step 3, we're told to eliminate all variable terms on one side of the equation. I'm seeing that I have a variable term over here and a variable term over here. So I need to get rid of one of these. Doesn't matter which one, pick one and commit to it. If we're going to use the hint, I'm going to get rid of the lower valued one, which is this 4x here. So it's a positive 4x, which means I'm going to have to subtract 4x to get rid of that. On the left side, I'm left over with 10x. On the other side, I have negative 80. And again, similar to our first example, I don't actually have any other terms on this left side. I just have the variable term, no constants over here. So great, step 4 is also done for me. Fantastic. Going to step 5, I can now isolate this variable by getting rid of this 10. The 10 is attached through multiplication, so I'm going to undo that by using some division here. So I'm dividing both sides by 10. The leftover stuff on the left side is just going to be the x. The 10s cancel out. X always remains. I have negative 80 divided by 10. Quick mental math, that's going to give me negative 8 there. Can't simplify anything else any further. That's going to be our final answer for number 2. Okay, example 3. Again, a little bit more advanced stuff showing up here, and this is why we want to see some examples with this. See the really weird things that they can throw at us in different textbooks and online resources. So looking at this thing, I have 3x plus 2 is equal to negative 5x minus the quantity 7x plus 3. And again, we're going to follow the exact same process that we did previously and let that guide us to the answer. So I'm going to be solving this equation for x. Fantastic. I'm noticing I have x's on both sides, so I'm probably going to need to eliminate one of them later on. If you're looking ahead and thinking that and seeing that, great. Nice to see that. We still want to follow our process as it's been described to us. So simplifying the left side first. 3x plus 2. I can't combine any like terms over here. I have a variable term and I have a constant term. And again, these things cannot combine together. They need to stay separated. That's fine. We'll leave that side as it is. On the opposite side, I have negative 5x minus the quantity 7x plus 3. This negative is going to have to distribute through to everything inside the parentheses. If need be, you can think of there being this invisible negative 1 that's there. So a negative 1 is going to multiply to 7x, and negative 1 is going to multiply to 3. I'm going to write the results right down below here. So this negative 5x isn't changing. It's just sitting out there doing its own thing. So you have negative 1 times 7x. That's going to give me negative 7x. I also have negative 1 times a positive 3. That's going to give me a negative 3. At the very least, using our PEMDAS process, now the multiplication and the parentheses are gone. I can now add and subtract things together and combine like terms on this right side. Really, again, we're trying to condense things down so this is as simple as it possibly can be. I have two variable terms on this side. Let's combine those together. Negative 5x minus 7x means I'm going to go more negative, which means I'm going to have negative 12x minus 3 at the very end here. Again, variable terms and constant terms can't combine together. They need to stay separated. So this is as far as I can go with simplifying the right side down. Look back at the left side. We've got some blank spots over here. Let's go ahead and fill those in. Nothing wrong with filling these things in with the exact same stuff as was written above. We need to get comfortable with doing that, and there's nothing wrong with doing that. Okay, so we've got a little bit more stuff going on both sides of this equation compared to our previous examples, which means we're probably going to need to use all of our steps to get that x all by itself. So, eliminating all variable terms on one side of the equation. Again, I'm noticing I have x's over here and I have x's over here. So I need to get rid of one of those, either this 3x or the negative 12x. Using the hint from our process, I'm going to get rid of the lower valued one. So which one between the 3x and the negative 12x is the lower valued one? If you're ever unsure which one to think is the lower value, here's a great little hint you can use. Which of these values, $3 or negative $12, is lower? And yeah, it's going to be the negative 12 here. No one wants negative $12. You don't want to be in debt to anyone. So that's a nice little hint you can use if that's helpful to figure out which one to eliminate, which one is lower. So this negative 12x is the lower one. I want to get rid of that. The sign in front is negative, so I want to do the opposite of that, which means I'm going to add 12x to this right side of the equation. If I'm adding 12x over here, I need to also add 12x over here. The result on this left side is going to be 15x plus 2. And on the opposite side, the negative 12x should be canceling out, and all that's left over is this minus 3. So fantastic. Now I only have variable terms on the left side of this equation. That's exactly what we wanted. So now step 4 gets to come into play. I'm going to isolate the variable term on one side by eliminating all constant terms on that same side. So we look at this and we say I have a variable term here, I should say, and I have a constant term over here. Again, my goal is to get x all by itself on one side of this equation. So I need to get rid of this plus 2 over here because I want to get the variable term alone. So I'm going to get rid of this plus 2 by subtracting 2 to both sides of this equation. What's left over? Well, on the left side I have 15x. On the other side I get negative 5 minus 3, or negative 3 minus 2. I'm going more negative, which means I'm getting a minus 5 here. Looking at step 5, we're going to isolate the variable by eliminating the value and sign attached to that variable. In other words, the coefficient. So I want to get rid of this 15 that's multiplying with the x. I undo multiplication with division, which means I'm going to divide both sides by 15. Running out of space here, so I can scroll this down just a little bit. There we go. I'm going to have x equals negative 5 over 15 here. Now we have a fraction answer. We always like to reduce our fractions down if we can. So 5 and 15, both of these can be divided by 5, which means this thing is going to simplify down to negative 1 over 3 for our final answer. Alrighty, everything's been building up. Here we are at example 4, and look at this mess of stuff that's been given to us. It's problems like this that I Really recommend that we lean on the second step in our process, simplifying both sides of this equation individually. A lot of people like to do parts of this, move things over, parts of here, move it over, then move other stuff over, and move it back and forth, and it's a complete mess that way. So lean on this process, let it tell you and guide you to the answer. There's not a lot of guesswork that needs to happen along the way if you let the process pretty much just tell you what to do from the first step to the next. So we're solving for a W here. We have W's on both sides. Yeah, we're probably going to need to use every step of our process here. But again, our goal is to get W all by itself on one side of this equation. Doesn't matter which side, just all by itself on one side. So let's start with simplifying the left side of this equation. Again, as necessary, and I think it can be very helpful, block this right side with a note card or something like that, just so you're not tempted to look at it early. Let's simplify just this side and see what we get from there. So simplifying this left side, I have 9w minus 7. I have nothing in front here that's multiplying to it. If you wanted to fit in an invisible 1 in front there, you could. However, 1 multiplying through, 1 times anything is just going to give us what we originally started with. So this is going to remain as 9w minus 7. Our next part, we have this negative 3 times the quantity 10 minus w. So this negative 3 is going to multiply to the 10, and it's also going to multiply to this negative w. So we're going to have some sign changes showing up here, so keep track of that as well. That's another tricky part with these problems is the sign changes. Negative signs are a little bit of a pain, and I think that's very much an understatement. So keep track of that as you're going through these problems. Negative 3 times 10, spoiler, gives us negative 30, and the negative 3 times negative w, that's going to give us a positive 3w. Now I can simplify this left side down further. I have w's over here, and I also have constants over here. So let's combine like terms. I'm going to combine the w's, and I'm going to get, what's that, 9 plus 3, that's going to give me 12w. I have negative 7 minus 3, I'm going to get more negative, so I'm going to have negative 37 showing up here. Awesome. Can I combine anything else? No. I have a single variable term, and I have a single constant term. I can't combine them any further. This is as far as I can go. And oh man, look at that. 2 steps. This is way nicer to look at than what we originally had. Maybe not the nicest thing in the world, but at least nicer than what we started with. Let's look at the right side here. So I have negative 5 times 4w plus 4 plus w at the very end here. And again, we're going to use the distributive property. This negative 5 is going to multiply to everything inside this set of parentheses. We're going to have sign changes taking place. So negative 5 times 4w, that's going to give me negative 20w. Negative 5 times 4, that's going to give me negative 20. Then I have plus w hanging out here at the very end. Can I simplify this down and combine any other like terms? You bet we can. We have a variable term here. We have a variable term here. Let's combine those things together. So negative 20 plus, there's an invisible 1 hanging out here. If you need to write that in for yourself, you can. It's regularly not written in, but you can if that'd be helpful. So negative 20 plus 1, that's going to give me negative 19w minus 20. And now I've fully simplified both sides of my equation, and we look at this thing and say, wow, this is much nicer to look at and work with than what we originally started. The really great part about this also is if you are following the process, especially the second step where we are just simplifying both sides of this equation, this is as complex as it can be when you simplify both sides down. And now we move on to steps 3, 4, and 5, and we're only 3 steps away from being done and at our final answer. So step 3, I eliminate all variable terms on one side of the equation. I have w's over here, w's over here. My hint, get rid of the one with the lower valued coefficient. So between 12 and negative 19 is the lower value. So I'm going to eliminate that. Let's make that a better 19. There we go. So I'm adding 19w to the right side, which means I'm also adding 19w to the left side. When I combine these together, on the left side, I'm getting, what's that going to be, 31w? Yeah. We're going to have 31w minus 37, and that's going to equal negative 20. Fantastic. We have all of our variable terms on one side now, and I want to get rid of any and all constant terms that are also over here. So I'm going to have to add 37 to both sides of this equation. I want to get rid of this particular constant term, step 4. So I'm going to add 37 to the left side, add 37 to the right side. What's left over? I have 31w on the left side, and I have, I think that's going to be positive 17 on the right side. And now I want to get rid of this coefficient in front of the w. So step 5 says to isolate the variable by eliminating the coefficient. This 31 is attached through multiplication, so I'm going to divide both sides by 31. So if I can zoom this out a little bit and give us some space. There we go. And I'm going to get w is equal to 17 over 31. I always check to see, can I reduce this fraction down any further? And while it's good to check for that, these are both prime numbers, so we can't divide them any further. And here we have our final answer. So some quick thoughts and observations that I do want to note with our 4 examples before we go back and summarize, recap what we did. If you were writing these down and going along with this, you may be noticing that in our second to last step when we are dividing with each of these, notice how we're dividing by a positive number here. In our second example, we also divided by a positive number. Third one, we divided by a positive number. In our fourth one, we also divided by a positive number here. The reason for this is because if we follow the hint that was listed in our third step, which was to eliminate the lower valued variable term from both sides of the equation, then we are always going to end up with a positive number in our second to last step. Therefore, we always divide by a positive number at the very end here. What's really nice about this is we don't need to worry about potential sign changes that will show up if we divide by a negative number. Remember, dividing by a negative is always going to flip the sign of the number right before it. So if we follow this process, yeah, we don't need to ever worry about sign changes in our second to last step of our problem. Other thing that I do want to note as well, and I think number 4 here highlights this very well, a lot of people from this second line of work will be very tempted to start adding and subtracting things to both sides of the equation. There isn't anything wrong with doing that, but notice that we would end up needing to we need to add 20 to both sides, and then we need to figure out, okay, am I going to add the 20 to this 3w or add it to the 9w? And very often I see people add 20 here and add 20 here. So we kind of overdo it with adding things together. And things go horribly wrong if we do that. So this is why I recommend condensing things down on each side as much as you possibly can. That way it's just one single thing that's being added to both sides, or one single thing, I think it was in one of our previous ones. Yeah, something like this. Or it's one single thing that's just subtracting from both sides, rather than having to worry about, 3, 4, 5 different things adding, subtracting all at once. So just a couple points I wanted to reiterate there and highlight for us as to why this process is so useful and why I recommend it so much as we're going through and solving these things. So as a quick recap of what we covered today, we were solving linear equations with variables. We wanted to identify what we're solving for. We're simplifying both sides of the equation Whenever we are simplifying, we're using PEMDAS, our order of operations. That's discussed in a previous video if necessary, or other videos on this channel if you'd like to check those out. We then eliminate all variable terms on one side of the equation with addition subtraction. We isolate the variable term on one side by getting rid of all constant terms with addition and subtraction. And then we get rid of any and all coefficients that aren't 1 by using multiplication or division. We didn't check any of our final answers. It is technically optional, but it is something that you can do and use PEMDAS to simplify each side of the equation individually. We had our 4 problems that we had right here and our answers. Pretty sure we got all of them right as we were going through those. I do also have some extra problems here if you would like to give them a try. Normally I go through these in groups in my class, but we have we've got 8 examples here for it, 4 groups, 8 examples total. So if you'd like to, I recommend pausing the video here so you can write these down and either try them for yourself or try a couple of them, pick and choose. I'm going to scroll us down here and get us to our answers for each of these here shortly. Alright, and here we have our answers to each of the problems. Hopefully you leaned on the process that we use. Let that reveal the answer to you rather than you forcing the answer, forcing an outcome that you want to be the case. I really feel that leaning on that and just letting it reveal what's going to happen makes these problems a lot less stressful as well. So hopefully that's been helpful, and that's everything with solving linear equations.